Hello guys, today we're doing LeetCode question 54, spiral matrix. This is a medium question. The question is, given an m by n matrix, return all elements of the matrix in spiral order. So spiral order pretty much means, as you can see here, it's in a spiral. So the matrix is 1, 2, 3, 4, 5, 6, 7, and 9, but return in order 1, 2, 3, 6, 9, 8, 7, 4, 5. Same here, 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7. So the way we'll do this is by just creating an array, creating a top value, a left, a right, bottom value, and we just check, we loop through the whole spiral until the array is smaller than, while the array is smaller than the matrix length, or the amount of elements in the matrix. And each time we loop, let's say a row here, we decrement the top by 1, so we already know we check this. Now we go right, we remove this, we go up, we remove these values. Now there's only 4, 5 left. We go right from 4, with these values to the left. So I'll show you how to do it in the whiteboard so it makes more sense. So let's say here we have our matrix of 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're gonna have an array here, which is empty. So we'll get our length by just timesing the array length by the array length. So 3 by 3 is equal to 9. So let's write our length here. So length to 9. We have a top value, which we set here, a left value, which is also set here, then a bottom value here, and right value here as well, or we can set here. Either way, doesn't matter. It just represents that this whole line here for the right value, this whole line here for the bottom value, this whole line here for the top value, this whole line here for the left value. So we'll have here left set to position of 0, we set right to position of array length -1, which is 2, we set top to 0, and bottom to again array 0 length, which is 2, -1 I mean, sorry, array 0 length -2, which is 1. So we loop from left to right, so let's say from 1 to 3 first. So now we push each value 1 by 1. So now we're at 1, we push 1 into the array. So open the array up to make it more clear. Now we'll have 1, then we go to the next value, 2, the next value 3. Now that we know that we completed this whole row, we can decrement top by 1. So we increment top by 1, signifying that we've cleared the top row. So now top is 1. Then we loop through 3, 6, 9. So we start from top. So we've already done 3, so now we go to 6. We have 6 here, and then 9. Now to signify we've done all of the right side, or the right row, we decrement right as well. So now right is equal to 1. And now we start looping the bottom row. We start from the right value and we go down. So we do this from right until 0. So now we're at right, we'll check is 8, or we add 8 to the thing here. We go left again, 7, we add that. Now we've looped through the bottom row, we decrement bottom. Bottom is now 1. So now we have to go to clear the bottom row. So let's just remove these. Bottom is now here, and right is now here. So now from 7 to 1, we've done 7, go up to 4. We add 4 here, we've already done 1. So now we have to do this row again. Now we've already done 4. And after, sorry, I forgot to mention, after we do the left column, we then go move left by 1. So left is now 1. So we go from 4, this row here, we've done 4, so we start from left, which is 5, and now we had 5, and our array is equal to 9 of length, so we stop and we return the array. So now let me try to do this code. So first thing we do is we create an array, an empty array, to store our order. So in case 1. Then we create our left value, which is left, which equals to 0. Let right, which is equal to what was it? Matrix. So the first array of the array length -1. Then we do top, which equals to 0. Let top equals 0. And we do bottom, which is equal to, again, matrix, but matrix length -1. Now we create a size, which represents the length of the matrix, or elements in the matrix, which is just matrix dot length, or we can just do, let's do matrix dot length times matrix 0 dot length. So the rows times the columns. So we know we have 9 elements. 3 times 3 is 9. And then let size is equal to. Then we loop through the matrix while the array dot length is smaller than the size. Now we have to loop through the first array, so through the first row. So we check for let I is equal to the left value. Then we, as long as I is smaller than right, smaller than equals to right, because we're traversing from left to right, then we increment I. And we push to the array current matrix value. Oh no, sorry. Current matrix value of I. So column I. Sorry, matrix value of top column, and each row. So top row, each column in that row. Sorry. And now that we've done the top row, we just signify we've done it. So we increment top, signify we've done row. Then we do the same for the last column. So we loop through for let I is equal to top. As long as I is smaller than or equal to bottom, we increment I. So we push into the array column I, which is the last one, and a row of right, because it's the right row we're doing first. And then after we've done that, we then decrement right, signifying we've done the right column, yes. Then we do the same for the bottom row. So for let I is equal to right, so we start from the right to the left. As long as I is smaller than left, or smaller than or equal to, smaller than or equal to left, then we decrement I, because we go from right to left. And then we push into the array the bottom, the bottom row, and the current column, which is I. I think I'm doing this incorrect. So matrix top, this is the column, this is the row, column. Oh, okay, no, it's correct, yeah. Yeah, okay. And then now to signify we've done a bottom row, again, decrement bottom. Sure, we don't have to do that anymore. And finally, we have to do the left column, the first column. So we loop for let I is equal to bottom. We go from bottom to top. As long as I is smaller than or equal to top, then we decrement I. We push a value in the array. So matrix column of left and row of I. And then to signify we've done this, we increment left, because we've just done the left row. and then we return the array. Let's see if that passes. Alright, smaller size. F++, time limit exceeded. Small to right, small to right, small to left. Right push. I see. This has to be small equal to right. I right has to be bigger than or equal to left, and this has to be bigger than or equal to left, because we're decrementing. Let's now run again. Okay, 1, 2, 3, 6, 9, 8, 7, 2, 5, 7, 2. How do we get 2? Let's bring the top and let's bring it to the left. Okay, so let I is equal to left, as long as I is equal to right, I plus plus, we're going to push matrix top. I'll see. Here, the column is I, the row is left. Now let's farm. Okay, this one passes, shows the function is correct, but it keeps iterating. So after we go to the last row here, 1, 2, 3, 4, 5, 6, 12, 11, 10, 9, 5, we again 6, 7, we again add 6. We can't go down, we can only go left. So what we have to do is we have to check in each position, because as the while loop will not check until we finish looping the for loop, we have to check that in each position the array length is also smaller than size, while and I is smaller, or I matches the current case. So let's go here, Control V, so add and statement, and now let's run, let's see. Perfect, that passes, let's submit. As you can see, this beats pretty much everyone for runtime complexity, for space complexity, sorry, and most people, almost everyone, for time complexity as well. This is a time complexity of OM of n. As worst case, well, we are not worst case, we are looping through the whole length and the whole height of the matrix, and the space complexity is also OM of n, so we're storing the whole matrix. So that OM for the length of the matrix and ON for the height, or for time and space. Thanks for watching.